All right. Hi, everyone. I'm Graham Lederer, and I'm a geologist. It's often said in my field that the best geologists are those that see the most rocks. In the age of artificial intelligence, the same can be said of predictive models. Those exposed to the largest quantity and highest quality training data tend to perform better. Over the last several decades, we've digitized the world's libraries. This has enabled a vast corpus of tokenizable text and led to the development of large language models. I believe a similar revolution is possible in the earth sciences, but only if we create that tokenized version of the Earth's crust. And thus, the Origin Project was born, an open resource of geoscience exploration. What if you could ask the Earth questions and get timely data-driven answers? Things like, where are critical minerals located? How much groundwater is in an aquifer? How sure are we that there are accumulations of geologic hydrogen or geothermal potential? The answers to these questions determine whether our future will be one of scarcity and conflict or one of abundance and wise resource stewardship. So our aim is pretty clear. It's to create the infrastructure layer that's missing currently. An open geoscience repository that will enable a revolution in data integration and frontier modeling. We have the data. A lot of that data currently is inaccessible to AI models. We've built some of the tools, but what's missing is this infrastructure layer, and it has to be open. We currently know less about the Earth's subsurface than we do the surface of Mars. And that's despite the uppermost few kilometers providing everything that Earth or modern society needs: energy, minerals, water, even construction materials and infrastructure. We've only directly sampled less than 1/1,000,000% of Earth's crust. And yet, we've spent trillions in sunk cost collecting and analyzing that data, tens to billions each year. This data exists, but it's siloed, locked away, inaccessible to AI. It sits in PDFs of borehole logs or geologic maps, geophysical surveys, and legacy formats. A lot of these reside in institutional archives that don't have the funds to transform them, make them AI ready. And where this work has been done in jurisdictions like Australia, there's an enormous return on investment. Geoscience Australia calculates for every dollar spent on pre-competitive geoscience data, there's a $500 return to the Australian economy. So multiply that globally, and it's a very large impact for a very modest investment. However, the private sector is unlikely to solve this alone. As one mining company executive told me, they go where the data are, not necessarily where the resources are, but where the de-risked information is available to them. So our plan is to teach a machine how to interpret the Earth. And we have a playbook. We've done part of this as part of a DARPA, ARPA-E, USGS program known as Critical Mass, where we trained AI/ML models to interpret a geologic map, combine that with other layers, and make predictive maps. Our ambition here is larger. We're looking deeper, considering the third dimension, depth. We're looking broader across different commodity types and resources, and we're looking wider in other geographic areas. And to do all of this in 3 phases: building the extraction tools, building an open repository of federated, harmonized data, and then a baseline model from the public data that others can use as a benchmark for comparative studies. How we're doing this is through a frontier research contractor. So Jotaware, where I work, has a track record of performing on DARPA programs as well as philanthropic efforts. And we're partnering with the USGS, national labs, state geologic surveys, and universities. We're seeking $5 million over 3 years, and this would allow us to accelerate our work and hit these milestones of having extraction pipelines online for anyone to use, creating these federated data schemas and populating them with the existing siloed data, and then ultimately producing these subsurface foundation models which serve as a baseline for the industry. So with that, I hope you'll consider joining the Origin project, where we're going to curate the underground truth. Thank you.